Hey everyone, I'm meteorologist Mark Collins. Going to recap what happened yesterday on Tuesday with that waterspout that came through Tampa Bay, just north of the Gandy Bridge, between the Gandy and the Howard Franklin. Had a pretty impressive waterspout captured on video. You can see some of the damage here in this photo. This was on Gandy Boulevard due to the strong winds that came through, toppling some power lines and shutting down the road, making it difficult for folks to get home. It was a very heavy rainstorm. In fact, Tampa International had record rains. 2.12 inches of rain fell at the airport, and that was just in 1 hour's time. So really heavy downpours. I stopped the radar here at 7:01 because the tower at MacDill Air Force Base, they were tracking this waterspout for around 15 minutes as it came through South Tampa over MacDill, and really the funnel started to descend over Tampa Bay. It was just the heavy rains that came over land there. This is the NEXRAD, the WSR 88D that's headquartered there at Ruskin's, and it is very powerful radar. It can actually cut through some of the heavier bands of rain without getting attenuated, and this shows that cell here developing. And what we were seeing yesterday is very warm water temperatures in the upper 80s in Tampa Bay, and the winds aloft were very light. Unlike the supercells that you see in the plains, waterspouts develop when winds are fairly light, so there's no shear. That way, on the warm water, you get these tubes, these vertical vorticity tubes, and we were seeing some outflow boundaries. So winds were going this direction, winds were going this direction at the surface, and it created these spinning columns of vorticity. And when we got these updrafts late in the day, it actually stretched the column tight, and like a figure skater, when the vortex contracts, the winds speed up in that vortex, and we're seeing the waterspout. So this was the time when we were seeing the waterspouts, and very interestingly enough, you can see how that rain moved out towards the beaches, and this is an image that the National Weather Service office in Ruskin sent out showing the terminal Doppler weather radar. These are radars which are less powerful. They can't see as far out, but they have much better detail. They're used at airports to actually see wind shear on the runways. And although they can't really see too good more than 55 miles out from the center, which is located at MacDill Air Force Base, notice how it picks out exactly where that vortex was yesterday. So you can see in this image here, there's the spiral of the waterspout, and you can see it here and here. And this is the actual winds within the waterspout. The red are outbound winds, the green are winds coming into the radar. So you can see exactly how these winds were rotating around the vortex. So it's pretty impressive to see that from the high-res 5-centimeter radar. The radar is basically at 5 centimeters, the same size as the hydrometeor, the raindrop, and that's why it gets attenuated and really can't see out too far versus the 10-centimeter radar that's used at the NEXRAD product that I showed you earlier. So if you want to see the details of a storm which is within 30 miles of the radar, which is where this waterspout was, very perfectly placed, this is a great tool to use to see these interesting details. We'll see you.